So these are my notes for 5.1a, defining rational expressions. So for this section, when we're talking about rational expressions, we're basically talking about fractions, but with like polynomials in them. So they'll have like an equation at the top and an equation at the bottom, basically, or one or the other. So whenever we're talking about stuff that's rational, which is something like this, okay, some polynomial over some other polynomial. So let's say that where P and Q are polynomials. Well, in any type of fraction, remember you can't have 0 in the denominator, so that goes for this as well. Q cannot be equal to 0. So what we're going to be doing at the beginning of this is looking for what's called restrictions to make sure that we don't set that bottom part equal to 0, so we can't have 0 at the bottom. So what they're going to say for the beginning part is they're going to ask you to find restricted values of x for the rational expressions. So in a case like what we're talking about, we'd have something like this. 4y plus 16 over 4y. Okay, so what we're doing is we're looking for what's going to make the denominator 0. So we're not worried about simplifying or anything just yet. All they want to know is what the restricted values are. So what you're doing is, all you're doing is worried about the denominator. You're taking the denominator and you're setting that equal to 0, and then solving for the variable that's down there to be able to determine what cannot equal to 0. Okay, what the restriction would be. Okay, so if we solve this, we can divide out the 4, and we would get y equal to 4. Meaning that if we would plug, well, y equal to 0, my bad. If we plug 0 into this, it would make the denominator 0. 4 times 0 is 0. Well, we don't want that to happen. So our restricted value, so restrictions, would be y cannot equal 0. Okay, we don't want y equal to 0, so you would state this. Usually in the thing, you would just have to put it in the 0 in the box. They would already have this y cannot equal or the x cannot equal or whatever from there. Okay, they don't all necessarily have to have restrictions. If you have something like negative 5x minus 4 over 5, well, there's no variable at the denominator. Okay, we're still finding our restrictions. 5 is never going to equal 0, so there are no restrictions. Okay, so some cases may not have restrictions just because there's no denominator in the bottom to make it. Let's see if we have something a little bit more in depth, like negative 7x squared plus 7 over 3x minus 2. Okay, again, we just want to know what the restrictions are. We're not trying to simplify or anything just yet. You can set the denominator part equal to 0 and then solve for x. So there's a little bit more to solve for this time. You add 2 to both sides, follow the same steps of solving an equation. Okay, so that would give us 3x equals 2. Then we'll divide by 3. X would be 2 over 3. Meaning that our restriction for this one is going to be x cannot equal 2 over 3. So you would put in 2 over 3 as your restriction. Okay, let's say we have this 5x over 2x squared plus 2x. Okay, some of these restrictions will require a little bit more work, like 2x squared plus 2x equal to 0. Again, set our denominator equal to 0. Well, in these cases, they don't have just one variable, so you'll have to do what we've done in the last test that we did. You'll have to do some factoring. So factoring will still come into play as long as there's like an x squared involved with it. More than likely you're going to have to factor. So both of these have x's in common, and they both have 2's in common. So we're going to do the factoring where we divide out the greatest common factor, giving us 2x in the front, and then we'd have x plus 1 left over. Okay, this divided by 2x and this divided by 2x is x plus 1. So then remember, you separate it and set each of these equal to 0, and you'll find both of your answers, so meaning that you'd have more than one restriction for this case. So here we divide by 2, x is 0. Here we're going to subtract 1, x is going to be negative 1, meaning the restrictions. So what's going to make this 0? If we plug in these two numbers, that would make the denominator 0. So that means we cannot use x is equal to 0 or negative 1. So either one of those would make that 0. Both of those would be our restrictions. So more than likely it's going to ask you to separate the answers by a comma, so you would just put them like this. Unless they have two separate blanks for them, then you would enter them in separately. Okay, some of these may also ask you to simplify as well. So they'll say, let's see, reduce, I think. Yes, so reduce to the lowest terms, and then give the restrictions. So they're still going to have to give the restrictions for these. They just want you to simplify it first. So let's look at an example like that. They may give us let's say x squared minus 9 over 2x plus 6. So for the ones like this where they want you to reduce first, okay, meaning you're going to have to factor the top and the bottom. So factor top and bottom, the numerator and the denominator, okay, and then cancel out the common terms that they have. Okay, so we're not trying to just worry about the denominator this time. We want to reduce it, so you have to factor this out first, both the top and the bottom. So this is a difference of squares, x squared and 9, that's x and 3. So that would become x plus 3, x minus 3. And then here we have 2 in common. So we'd have to divide out the 2 that they have in common, factor it out from the last test as well. So that would be 2 parentheses x plus 3. Okay, both of these divide out by 2. This factors out into a difference of squares. So now we can see that there's an x plus 3 at the top and an x plus 3 at the bottom. Okay, as long as there's one pair, you would cancel that pair out. Okay, then you would have x minus 3 left at the top and 2 left at the bottom. So this would be your reduced form. So this is considered reduced after you cancel out all of the factors that were left. So then we're going to have to find the restrictions. Well, you can't use the part where you cancel stuff out. You don't want to use this answer and set this denominator equal to 0. You have to go back to the original denominator or the denominator right before you cancel stuff out. So usually it's easier to do the factored out denominator. So that's what I'm going to do. We're going to use this right here where before we crossed it out. So we're going to do 2 times x plus 3 equal to 0, and then we'll find our restrictions like we did on the previous examples. So same thing, set both of these equal to 0. Well, in this case 2 can never equal 0, so this isn't going to work. But over here we can subtract 3 and solve for our x. So x is equal to negative 3, meaning that our restriction would be x cannot equal negative 3. So that's what you would enter in for the restriction. It may give it to you in 2 steps. You would enter in this at the first answer and then this afterwards in the second answer, or in step 2. Okay, so they'll have multiple things like that. Let's say we have another one.